general concept of solving trig functions is that we want to isolate the trig function, and then we want to use kind of like the inverse, where if you are given the trig value, you want to give the angle that trig value exists. And we said to sine and cosine. So if I had something like let's say 3 minus 6 sine of theta equals 0, okay? I would subtract the 3, negative 6 sine theta would equal negative 3, divide both sides by negative 6, and I end up with sine of theta equals a positive 1/2. And then I want to reference my unit circle. I want to look at my whole circle and find everywhere sine, which is my y, is a positive 1/2. So that's going to happen at pi over 6 and at 5 pi over 6. And to those, we are going to add 2n pi. Because not only is that answer occurring at that location on the original unit circle, but it is occurring at every coterminal to that angle, which means the 2n pi. So if I added 2n pi, 4n pi, 6n pi, 8n pi, and keep going, that same value would occur.
So for what I remember yesterday, if we're working with sine or cosine, and so if we're working with that, we solve for like the equation we're given, and then we go to like either x or y because of sine and cosine. And we take, I don't know what that's called. When
The radian value, yeah.
The radian, and then we add 2n pi, but if it's tangent, we add
So let's say tangent was negative root 3. First, I would fill in my unit circle with the tangent. So 0, root 3 over 3, 1, root 3, undefined. And I would do the first and second quadrants. This is again 0. This is negative root 3 over 3. This is negative 1, and this is negative root 3. So with tangent, not only do we not have to worry about the whole circle, well, we add 2n pi, and that's why we don't have to worry about the whole circle, because n pi means half a circle. So if I'm looking for where on my unit circle tangent is negative root 3, I would look in the first two quadrants. I would find that it's here at 2 pi over 3, and then I would add n pi to it. Because by adding n pi, we add half a circle. So that would really take us also to 5 pi over 3, which is why we don't have to include the whole circle in our first answer. If it had said on the interval 0 to 2 pi, then I include everything that's on this circle. Everything that's on that printed circle as an answer I would include. But if it just says, if it doesn't give you the interval, then you have to add the 2n pi or the n pi, and for tangent, you only need to include quadrants 1 and 2.
And then when, like if it was the ones where it's like the plus and minus.
Yep. So if this was plus and minus root 3, now it's going to be both pi over 3 and pi, and 2 pi over 3.
Because they would repeat, so you cancel out the other.
Correct. If this was plus and minus, it would be all the over 6's. So it would be 7 pi over 6 and 11 pi over 6.
But like, oh no, I'm not going to say that now. Because you start, I was going to say, like, what if you chose like the 7 pi over 6 and the 11 pi over 6 instead of the pi over 6 and the 5 pi over 6?
So those are the negative 1/2. Yeah. I added them because I changed it to plus or minus, but if it had just said plus, you couldn't do it. Okay, so from yesterday and we left off, so here's a review. Like that's basically, because that's the top, how we did it. We left off on these. So this is where it gets a little bit trickier, because those are two different trig functions, right? Two different trig functions. It can't be factored, so it's not like I can split them and solve them. And neither of those is squared where I can replace it with its Pythagorean part of the Pythagorean triple, right? That's what we used yesterday, the Pythagorean identities, if it was squared. So we have to create that by actually squaring both sides of these equations. So I'm going to square both sides. And when you do, the right side gets sine squared x. The left side, you actually have to expand and FOIL. So cosine x plus 1, cosine x plus 1. Cosine times cosine is cosine squared x. Cosine times 1, positive cosine. 1 times cosine, positive cosine. And 1 times 1, positive 1. Then I can combine my like terms, so cosine squared x plus 2 cosine x plus 1 equals sine squared x. Now, right now, I still have two different trig functions, but because I have a sine squared, what can I do with that? Good. Because sine squared plus cosine squared equals 1, I can replace sine squared with 1 minus cosine squared. So now I can rewrite this as cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. And now I can get everything to one side to factor it. So I would add the cosine squared x and subtract the 1. I get 2 cosine squared x plus 2 cosine x. These cancel, equals 0. And then how do you factor that? Take out 2 cosine x, and I get cosine x plus 1. And now I can split and solve these. So this divide by 2, and I get cosine x equals 0. This one subtract the 1, and I get cosine equals -1. So then I need my unit circle again. And I'm looking for two things. First is where cosine is 0. Now notice this says on the interval of 0 to 2 pi. So I get cosine of 0 would happen at, so where's the x 0? It's at pi over 2 and at 3 pi over 2. And where is cosine -1? And that's at pi.
Oh, I have a question.
Yeah.
When you're looking at the one to the right, like the 1 0 point, how would you know when to use
The 1 0. Say that again.
when you're looking
This.
No, like on the you do the circle.
Oh, yeah.
Like how would you know when to use 0 and when to use 2 pi? Like.
So if you always start with 0,
Okay.
right? And if it says don't put it on an interval, 0 plus 2 pi is 2 pi. So you already have it, you don't need it. If it's 0 to 2 pi like this, notice that the 0 gets the bracket and the parentheses gets the 2 pi. That means don't include 2 pi.
Okay.
So you always pick 0.
Okay.
It's this, do you add the 2 pi to it or do you not? If 2 and pi, not 2 pi, sorry.
Why did we
Because you can't factor it, and there was nothing squared, which is the only other way that we can replace things. You basically have to get it to a point in which you can.
So if you can't factor anything, you can square.
You can square both sides all the time. It's just sometimes you don't need to. But here's the catch with this one. When you square both sides of your equation, you have to check for extraneous roots because you basically just pulled a root in there that may not exist. So the way we check for extraneous roots is we plug these values back in. So I would say, does the cosine of pi over 2 plus 1 equal the sine of pi over 2? Does the cosine of, what's the next one? 3 pi over 2 plus 1 equal the sine of 3 pi over 2? And does the cosine of pi plus 1 equal the sine of pi? So we have to check when we square. So what's the cosine at pi over 2?
0.
Sorry, let me move this. Yes, 0 is right. Okay, cosine at pi over 2, that's the x value at pi over 2, and that's 0. plus 1 equals, what's the sign at pi over 2?
Okay.
0.
Nope.
1.
1. Does 1 equal 1?
Yes.
Yes, so that answer I get to keep. Oh, where'd my answers go? That answer I get to keep.
I would go to cosine 3 pi over 2. So
Yep.
for x is 3 pi over 2,
And what's that?
the bottom,
What's the x there?
-1?
Nope.
Or no,
0 plus 1 equals, what's the sign there? -1. Does 1 equal -1? No, so we cannot use 3 pi over 2. It's an extraneous root. And then what's the cosine at pi?
So you have to check.
Yep.
And it's that one.
Miss Chris Weinzer,
Yeah.
I don't understand what you're doing to check. Like, I don't get it.
So we took our answers and we plugged them back into, you can't see it, well, we plugged them back into the original equation. So there was 3 answers, so we're checking all 3. The first was pi over 2, so everywhere there was an x, I'm plugging pi over 2. The second one was 3 pi over 2, so everywhere there's an x, I'm plugging in 3 pi over 2. And the third one was pi, so everywhere there's an x, I'm plugging in pi.
Okay, so if it doesn't equal the same, then it's not an answer.
Correct.
And then how did you get from like the cosine pi over 2 to like 0 plus 1?
So pi over 2 is up here, right? And the cosine is the x coordinate, so that's 0.
Oh, okay.
Does that make sense?
Yeah.
Okay, so at the last one, cosine of pi is -1 plus 1. Sine of pi is the y at pi, which is what?
Okay, thank you.
You're welcome.
0.
0. So 0 equals 0, which means I get to keep that one too. So the only extraneous root was 3 pi over 2, but that means my answers are pi over 2 and pi. So we check when we square both sides because you are basically bringing in a root that might not have happened. The other ones are fine because we already, those are exactly like you're solving it based on the original one, you're not altering it. All right. Same concept for 12, so you try it. Start by squaring both. Don't do that. Actually, no, that doesn't necessarily mean it's wrong. So this would be sine x, right? Plus 1 times sine x plus 1. Sine squared x plus sine x plus sine x plus 1 equals, and that's cosine squared. Which, oh good, 1 minus sine squared x. Oh, sine squared. She wasn't abused like this when she was at home by herself, you know. Unless your siblings or parents do that to you. Yeah. Oh, you texted her. She virtually did it. Subtract the 1, add the sine squared. And then it's the same. Take out a 2 sine this time, and I get sine x plus 1 equals 0. Split them, set them equal to 0. Sine would equal 0, and sine would equal -1. So then go to your unit circle. Sine is 0 at 0 and at pi. And it's -1 at pi, 3 pi over 2. Then we check these. So we plug them back in. Sine of 0 plus 1 equals cosine of 0. Sine of pi plus 1 equals cosine pi. And sine 3 pi over 2 plus 1 equals cosine 3 pi over 2. Okay, I'll give you a minute or two to catch up, but I can't go much more than that because we need to get through the multiple angle one.
So you, look at it, if you can't factor, you square, square, FOIL, factor, use the Pythagorean
Yeah.
identity. Use the Pythagorean identity for the other side if it's not the same, like,
Yes. You do that before you factor, actually.
yeah.
Yeah.
And then from there you like combine like terms to kind of get it equal to 0,
And then factor.
and you factor again. And then you look at your unit circle,
Yep.
so that way you can find the sines, cosines, tangents, whatever it is.
Yep.
Of those.
And now we're checking. So
Yeah,
this is
okay.
the check part.
Yep. Mhm.
So sine at 0 is 0 plus 1 equals the cosine of 0 is 1. That one works. Sine at pi is 0. Cosine at pi is negative 1. That one doesn't work, right? Sine, no, sorry. Yeah, no, I did that right. That one doesn't work. And then sine at 3 pi over 2 is negative 1 plus 1. Cosine at 3 pi over 2 is 0. 0 equals 0. And that one does work. So I rule out the pi, but I keep the other two.
Question.
Yeah.
On the next slide, is this supposed to, I don't know if there's a typo, if it's supposed to look like that.
It's supposed to look like that. Yep.
Okay.
Okay, so any one that has a number between the trig function and the variable are what we call multiple angle equations. So you'll see these mixed in on homework, but notice that they have something here, something there. Anytime that there's a number in between the trig function and the angle, and it's not squared because those we already know how to do, we do these a little bit differently. So if you've gotten distracted and you're trying to do your homework, please come back to me because this will get super confusing if you've gone to do this and then you come back to do it later. So for these, we are actually going to solve the way that we normally solve first. So I'm going to add the 1 to cosine 3 theta equals 1. I'm going to divide both sides by 2.
Oh, the T is a thing.
Not theta, sorry, t. It's
I make it an X.
still, you can make it whatever you want to make it. It's just a variable. And then from here, we're going to go to our unit circle. We're going to find where the angle is a half. So, where the cosine is a half. Cosine is a half at pi over 3 and 5 pi over 3. Plus 2n pi because it didn't give me an interval. Plus 2n pi because it didn't give me an interval. Normally we'd be done and we would say t equals that, right? That would be our answer. But this time 3t equals this, which means at the very end we have to divide by 3. And you have to divide not only the angle but also the interval.
Can we just leave it like that?
No. So dividing, same thing as multiplying by a third, multiply by a third, and I end up with t equals t over 9 plus 2n pi over 9.
So.
Hold that thought because I'm not done. I got to do it to the other one.
Okay.
Hold it.
Mm-hmm.
Divide by 3, divide by 3, divide by 3, and I get t equals 5 pi over 9, 2n pi over 3.
Why?
Oh, this should be 3, not 9. Just kidding.
2n.
I did it twice. Over 3. So my answers are pi over 9 plus 2n pi over 3 and 5 pi over 9 plus 2n pi.
Out of curiosity, would they ever give us this with an interval?
Yes.
What?
So.
Don't worry about it yet. Okay. Could it exist? Yes. Is it going to right now? No. Don't worry about it. I'm not even going to, because that'll freak you out and then we'll lose train of thought and then we won't be able to finish. We could talk about it tomorrow. Okay. All right. Next one I'm going to do kind of quickly because it's the same concept. I'm going to add the root 3 2 sine 2t equals root 3. Divide both sides by 2. Sine 2t equals square root 3 over 2. Go to my unit circle. Where is sine root 3 over 2? It's at positive pi over 3 plus 2n pi. And it's at 2t would equal 2 pi over 3 plus 2n pi. This time I'm dividing both sides by 2. So I get pi over 6 plus n pi, because the 2's are going to cancel, and 2 pi over 6, which becomes pi over 3, plus n pi. So if I divide this by 2 and divide this by 2, right, multiply by half, it's going to cancel the numerators.
So you ignore it till the very end, then it's another equation. It makes our life.
You change it after you find the angle.
Makes our lives harder because you have to do.
Sure, it's an extra step. Yeah.
What is it? Why is it there?
Why is it there? Because, like, in the grand scheme of angles, right, you can find, like, there may be times, and you're going to see, like, when we get to double angle, half angles, which you'll probably do with me next year if you take, you'll either do with me or Miss Boyd if you do that. There are unit circle angles in which you can't find the value when they're doubled, but you can find the value when they're halved, and you use a formula like a double angle like this. But this is just a different way to find it. So you'll see those again. You're going to see the little 2t's and 3t's and stuff like that again. I do them again next year, okay? Just understand that it's not the actual, like, the value of whatever. If I was to check these, when I plug that back in, you'd actually be duplicating. You'd be doubling that angle to find the sine of it. So instead of finding the sine of pi over 6, you'd be finding the sine of 2 times pi over 6, which is pi over 3.
Okay.
So if you were to check it, it would just double the angle.
So it's there because sometimes the angles you can't find them.
Yes, that's the reason why it's there. We just don't use it that way right now.
Right now it's just we
Yes.
can't use it for the reasons.
Yes. Okay, so the good news is that the last one is ugly. It's like you can't factor this, so you have to use the quadratic. This is not on your homework, but we will do this together tomorrow, okay? So it is, again, it's not on your homework, so I'm not going to stress about trying to do it in the next 10 seconds, okay? But you would have to do the quadratic formula there because it's not factorable.